This is the era of global warming and climate change. The Earth's temperature is going up. It's already gone up by about 1.5 degrees Celsius and is expected to hit 2 degrees Celsius. The impact of it is being felt all throughout the world, especially in India. We have heat waves hitting us. We have heavy rainfall and flooding, and in some places droughts. How can we as individual citizens in our cities try and cope with climate change and global warming? Can design help us to deal with it better? Can it help us to adapt to what would be infrequent weather conditions? High temperatures, high rainfall, sometimes less rainfall. What can we do with design? One way which we have been practicing in Bangalore city is to think about an individual home as to be climate change resilient. How do we then build this home? It's important for design to incorporate a semi-basement or a basement, sometimes called a cellar. The basement or cellar stays below the ground, is insulated by the earth, and is a thermally stable place. It stays warm in winter and cool in summer. We have to make sure that the groundwater table is below the basement floor level. The basement then provides the earth for the construction of the entire building. Dig out the earth, blend it with adequate amounts of clay or sand, depending on the properties of the earth, compress it in a mechanical compressor using human labor, and you have blocks ready to build the house. The basement can provide enough material for the whole house itself. Being built on site, it is very energy efficient. It does not require burning, and therefore it requires less fuel consumption and therefore less carbon emissions. These mud blocks or stabilized earth blocks become walls, can also become roofs. These earth block walls do not need any plaster, do not need any paint, and can be left exposed, thereby reducing material consumption and hence energy emissions. They form and blend with the environment, therefore they do not stand out and are part of nature. The other thing that we do with design is to make sure that the spaces so designed are open and naturally ventilated. In a city like Bangalore, it's possible to design even without fans, let alone air conditioners. Air conditioners now cause a lot of problems with urban heat island effects with the heat that they emit outside into the environment. So designing through natural ventilation, we are able to eliminate ACs, we are able to eliminate fans also. That is therefore making use of the second part of nature, which is air or wind, the first being earth. The third component of nature available on every site is water. Water comes in the form of rain. If we have a rain gauge on our terrace, what we are able to do is to understand rainfall patterns, and understanding rainfall patterns and total quantity of rainfall helps us to design rainwater harvesting systems. How do we then harvest rain? If we keep a clean catchment, let us say for example with the staircase roof, then you're able to collect water on the terrace itself in rain barrels. Rain barrels are plastic drums, HDPE drums, which store rainwater. This rainwater can then be brought down to the kitchen, for example, and then fed into a filter. Once rainwater is filtered, it can be used for drinking and cooking. Thanks to the evenly distributed rainfall in Bangalore, spread over 8 to 9 months, and with 970 millimeters of rain, even a small 500-liter rain barrel provides enough drinking and cooking water for the whole year. Rainwater is free from fluoride and nitrates, is free from salinity, and therefore does not require reverse osmosis or any other form of filtration, but basic biological filtration. The other components of rain that fall on the terrace can then be filtered using basic charcoal filters or ready-made filters available in the market, and then stored in underground sump tanks. This water can then be pumped up to overhead tanks and used for all other purposes in the house. A 100 square meter roof area in Bangalore harvests nearly 1 lakh liters of rain annually. More than sufficient for a family of 4 if we are water prudent and water conservative. The excess rainfall that flows out from the sump tank during heavy rain periods or continuous rain events can be put into something called a recharge well. Wells were traditional in our cities. They used to provide us water from shallow aquifers. They used to be fed by lakes and tanks, and they used to filter the water and be available throughout the year. We have lost the culture of the well in our cities. But through recharge wells, what we can do is to put excess rainwater and storm water into the shallow aquifer, bring up the groundwater table, and mitigate the impact of urban flooding. Reducing urban flooding, bringing up groundwater tables, in turn provides us supplemental water throughout the year. In Bangalore, with the help of the traditional well digging community, it is our goal to dig 1 million recharge wells so that livelihoods are provided to the traditional well digging community and the city becomes water resilient, flood resilient, and brings up its groundwater table. So every house can have a well, and 1 million wells is a distinct possibility. Rainwater, which is thus recharged into the aquifer, becomes available as groundwater throughout the year from bore wells and open wells. What do we do with efficient use of water? One of the things that we need to do is to put aerators in our taps, low flow showers, low flow flushes. By being conservative in water use, we're able to save 30 to 40% of water. The other thing we can do is to recycle grey water. Grey water is water which emerges from our bathrooms and our washing machines. When we have a bath or a shower, or when we wash our clothes, the water that comes out is called grey water. By using eco-friendly soaps and detergents made out of soap nuts and soap berries, we improve the quality of the grey water without compromising on our hygiene needs. For example, as a shampoo or as a soap or even as a detergent to wash utensils, soap nuts and soap berries can be used. The water then that comes out from these places, the washing machine and the showers, can be treated using small biological filters. And these biological filters, which use plants to filter the water, cleans it enough for it to be put to non-potable use. For example, watering the garden or for swabbing the floor. Grey water reuse saves a substantial portion of water and also has a second benefit. It does not leave the house and pollute the environment. If you are brave enough, you can also design what are called eco-sanitation toilets. Sustainable sanitation systems or eco-san toilets separate urine and feces. Urine can then be diluted and used as a fertilizer, and the solids can be composted on the terrace itself in blue drums and then be used as manure or soil conditioners for growing plants. This way again, no human waste leaves the house and therefore becomes productive. It is in turn a small fertilizer factory on the terrace itself. The terrace can be designed to grow plants. Not only they can grow vegetables, flowers, for biodiversity, for example, but also grains like rice and millets can be grown on the terrace if designed appropriately. Just a small pond lining material on the roof, 1 or 2 layers of it, about 1/3 compost, 1/3 of vermicompost, and 1/3 of soil, up to 3 inches thick, would be good enough to plant rice and grow rice crops on your terrace. You can actually get a kharif and a rabi crop. You can actually get 3 crops of rice on the terrace. And mind you, the water needed for the rice would come from the grey water that you treat, and the fertilizer needed for the rice could come from the eco-san toilet. About 40 kgs of rice can be grown on a 40 square meter terrace area per crop, which means that we can get up to 120 kgs of rice in a year, 120 kgs of paddy, which translates to about 80 kgs of rice in a year. And the house can be self-sufficient for its grain requirements too, through wise use of water and space. Energy is a crucial component of a house's functioning. By using solar photovoltaics, we can light up the house. By using solar water heaters, we can heat the water for our home requirements. And by using solar cookers, we can substitute for the gas that we use in our kitchens. And through solar cooking, you can get good cooked food, especially during summer times. It may not be possible during the monsoons. That's when you use other alternative forms of energy. We must remember to compost every gram of kitchen waste that we generate. All waste leaving the house should either be recycled, put to productive use, which is the dry waste component of it. The wet waste component of it can be composted in home-based composters or biogas digesters and then reused in the kitchen garden. Again, no solid waste need leave the house if designed properly. Energy requirements of the home can be met by the home itself or the roof itself. Therefore, the last component that we need to deal with in terms of design is biodiversity. The world is going through a species loss of monumental proportions. Insects, for example, are disappearing from the face of the earth, about 50 to 60% of the global insect population may have died out. How then do you enhance biodiversity? By cultivating crops on the terrace made specifically for insects. Wild flowers, weeds, which we call, and plants, which allow for a natural insect population to thrive, can also be planted in parts of the roof and therefore attract insects and biodiversity. Remember also to plant trees in and around the surrounding areas. A house design like this reduces energy needs by a dramatic 80%, water needs by almost 100% depending on the rainfall, and food requirements can come from the house design itself. How do we take this next step forward at a neighborhood level? A lake in Bangalore called Jakkur Lake is a standing example. A wastewater treatment plant set up upstream of the lake treats 15 million liters per day of wastewater and then lets it out into a wetland. The wetland is a biodiversity space which allows for nature to thrive. Small reptiles, mammals, and birds flourish in the wetlands. The wetland polishes the wastewater and treats the untreated wastewater also and leaves it into the water body. The water body, which is about 50 hectares in water spread, has a thriving fish population which fishermen cultivate. The Fishers Collective therefore earns a livelihood. The fish provides proteins for the city, and the fish in turn attracts birds like pelicans and painted storks, and now this place has become a biodiversity hotspot. The other benefit is treated wastewater entering the lake through the wetlands then recharges the groundwater, brings up the aquifer, and then becomes available as potable water for the city. Jakkur Lake in turn recharges close to 7 to 8 million liters per day, which is good enough for a population of 80,000. Thus, wastewater is turned into a resource through the intermediation of nature and through the intermediation of livelihoods. The final point that a city can do is to look at all its wastewater as productive water. The wastewater from the 33 wastewater treatment plants in Bangalore are treated to adequate standards and then pumped to the climate change affected districts of Kolar and Chikballapur, filling lakes. 137 lakes are being filled in Kolar district alone. These lakes in turn recharge the aquifer and become available as water for farmers. Farmers' livelihoods is ensured, and what the farmers produce as food comes back to the city in a circular economy operation, which brings food security for the city itself. Thereby, wastewater or used water becomes a resource, a water resource, a fertilizer resource, a resource for livelihoods of farmers, groundwater recharge, and then food security for the city. Circular economies can be practiced from a house level to a neighborhood level to the entire metropolis itself. This is the way we have to imagine urban India, starting from our homes, apartments, gated communities, neighborhoods, and the city itself, to be able to use water and energy wisely to make sure that we are able to adapt to the frequent weather changes that we are likely to experience and to become resilient.